registers inside the CPU, the accumulator, the program counter, memory buffer register, memory address register, input register, output register, and the instruction register. And I told you, if you exactly understand what's the main function of each register, you can simply and easily write the register transfer notation or the register transfer language. When we mention the RTL or we want to specify the RTL, we need to specify all the steps. For example, load X will copy the X address to the memory address register. 1 minute. So, load X, for example, we will copy the X to the memory address register, we will copy the data to the memory buffer register, then the data from the memory buffer register to the accumulator. We also explore the simple instructions of the Marie code, the instructions that we will use it to write our program. I will review them quickly before we start with the simple Marie code. Today I will cover the TMA material. Today also I will discuss with you the TMA. We will see how we can run a Marie code, and we will arrange for the in-class quiz next week. The paper-based quiz will be held next week. So we'll agree or arrange the time by the end of the class. Following are the first 9 instructions. We have explored them. For the Marie, you will use these instructions to answer the TMA actually. Some of them, you need the load, you need the store, you need the subtract, this one, and the skip condition. The output is needed, and for sure to terminate your code. Now, jump also you need it, or go to, you need it. Now, load X, what happened here? The value at address X or the content of address X will be what loaded from the computer memory inside the accumulator. Store X, copy the content of the accumulator to the address X. Now add X as the content of the accumulator. Suppose this one the accumulator, and suppose this one the address X. So here we have 10, here we have 5. So add X, it's like what? AC equal AC plus X. Okay, so what does add X will do? We will add the old accumulator value plus the data at address X, so it will be stored as a new value to the accumulator. So it will be 15. Subtract X will subtract the data or the content of address X from the content of the accumulator, will store the result in the accumulator. Input, read the data from the user. Input from the keyboard to the accumulator directly. Output, the value of the accumulator will be displayed as an out. Halt, terminate. Now jump X, add or load the value of address X inside the program counter. So jump X, the value of the PC or the value of X will be what? The X address will be the program counter value. Now skip condition, when we have a skip condition, we'll check the accumulator value. We'll see skip condition 0, 0, 0, which means the accumulator value less than 0. Skip condition 400, the accumulator value equals 0. Skip condition 800, the accumulator value greater than 0. If the condition is true, the next instruction will be skipped. So the program counter will be incremented by 1. If the condition is false, the next instruction will be executed. It would not be skipped. Also, we see how we can understand any instruction inside the ISA register. The bits between 12 and 15 is the operation code, and the bits from 0 to 11 are the address, the computer menu. So this was a quick revision for the previous class. One more time, if you understand exactly, clearly what's the task of each register, you can understand any Mary code. You can write the RTM or the RTL simply and easily, and you can solve any question. Now we'll start with a simple program and will enhance or extending our ISA. In other words, we have studied 9 instructions. We will add another 4 instructions to our ISA. The addressing mode, take a note, it will be a 10 marks out of 50, a final exam question. This model, it's very simple, it's very easy. You will solve the question, I will not solve it today. 10 marks. A question can be solved within 1 minute or 2 minutes maximum. So, let us start with our very simple and easy Mary code. Load 104, add 105, store 106, hard. Now, load 104, go to address 104, load or copy the content of address 124 to the accumulator. So what we have in address 104, 0023, this one in hexadecimal representation. So it's the number 35. So when we execute load 104, the accumulator value will be in decimal 35. Inside the address 104, we have the value 35 or 0023 in hexadecimal. Okay, now add 105. Copy the content of address 105, add it to the accumulator, and store the result inside the accumulator. Now in address 105, as you see here, we have the value FFE9. FFE9 in decimal, it's minus 23. So in address 105, we have minus 23. So what will be the new accumulator value when we execute add 105? 104 and 105, the X, the address. So if we have an address 104, 35, and an address 105 minus 23, after we execute the add, what's the accumulator value will be? What's the accumulator? 35 plus minus 23. So what's the accumulator? 35 plus minus 23. It will be 10 2. It will be 12. Now, store X, store 106. Copy the content of the accumulator to address 106. So we will have at address 106 the result is 12. Finally, halt, terminate, exit. So this one is simple code. You need to know, we write the instruction and the address. Add the address. store the address. As you see, this one is the ISA instruction. It's 1000, it's load. 11, number 3, add. Number 4, store. Number 7, HAL. And you know, HAL doesn't have any address because it means exit. So if we compare this number, it will be 104. This address 105. This address 106. So at address 104 we have the value 35. In address 105 we have the value minus 23. In address 106 the initial value 0. We must give it initial value. Then we will store the 12 inside. So what will happen exactly? We will read the value of address 105, we will read the value of address 104 for it. We will add the address of value 105 to the value inside the accumulator. We will store the result in the accumulator, then we will copy the accumulator to what? To the address 106. Now, last class we said in each clock tick the CPU will go through the von Neumann cycle or the CPU cycle, fetch, decode, execute. So what will happen exactly during the fetch, decode, execute cycle? This one, load 104. It's the RTM, by the way, the register transfer notation. In fetch, we will copy the value of the program counter to the memory address register. We start from 100. So the value of the program counter will be 100. Now we are executing the instruction 100. Remember, when we load it, when we read the instruction, after that the program counter will be 101. Because always the program counter value, the next instruction to be executed, not the current one. So hello, sorry, internet disconnect. So what we will do here, now, is it okay? Mu'taz, Fatma, okay? Fine. What we will do after we copy the instruction, we will increment the program counter by 1. So once we done with the fetch, what we have? Program counter 101. Inside the instruction register load is 1. Okay, the binary representation of, or the decimal representation of load is 1. 104 is the address. The memory address register is still 100. Now, we will go to the decoder. We need to understand what we have inside the instruction register. So we'll check the bits from 0 to 11. It will be the address. It will be taken to the memory address register. The bits between 12 and 15, the instruction register. So now we know that we are going to copy the content of the address 104. We change the memory address register. Finally, we fetch decode. We need to execute, but not all the data available. So we'll copy the content at address 104 to the memory buffer register 0023. Then from the memory buffer register to the accumulator. Once we finish this, we will have 23 in hexadecimal stored inside the accumulator. So fetch, decode, execute. And remember, during the fetching, the program counter incremented by 1. Clear? No need to memorize it, just understand what's the 104, which is the address. The memory address register will copy the address inside it. The memory buffer register, the data, always from the memory buffer register to the accumulator. عندكم سؤال على هذا? Do you have any question? here. Right. Same for add 105. We start with a program counter, we increment the program counter, we decode. Finally, as you see in add the content of the memory buffer register, which is the address 105, to the accumulator, store the result in the accumulator. So we have C in hexadecimal or 12 in decimal inside the accumulator. Store, we'll copy the accumulator value to the memory buffer register, then from the memory buffer register to the memory at address 106, which is stored inside the memory address register. So RTM, and what's the value of each register? Any question? أي سؤال على البرنامج؟ So load X, add Y, store W, half. Now, it's not simple, it's not easy to write the code with a memory address. Each time we need to write the memory address, 106, 104, 105. Can we enhance the program? Can we improve the writing style of the program and make it more readable? This is our simple program, by the way. The answer is yes. How we can improve our code? By using two enhancement tools, let me say, tools, directive and labels. And the most important one, the labels, not the directive. So the assembler directive, what's the assembler directive? It's an instruction that it's not supposed to be translated into machine code. It's like a comment. The comment will enhance my code, but it will not translate it to machine code. It will not execute it. Mainly, we have 4 directives can be used in the assembly code. The first one is called ORG, the organization, or ORG. The ORG directive control the starting address of the program. What does that mean? Always the ORG, by the way, you can write it in small case, uppercase, it doesn't matter. If I said ORG 300, what does that mean? My program will start from address 300. If I said ORG 200, so the program execution will start from address 200. What if we do not have ORG? The default execution address 100. Clear? Or 000H in hexadecimal. Clear? واضح ORG? It's an instruction, will not change the code now. We have another 3 directives can be used to specify the data type. Let me say it's used to control the data type. What's the value we'll use as an input and output? We can use DET, decimal, octal, hexadecimal. So the other 3 directives will enable you to put constants in your program. For example, my program will take the input as decimal, or as hexadecimal, or as octal. And always, okay, we need to write the label, comma, the directive, for example, the address X, comma, it's decimal, and for example, it will take the value 10. So address X, decimal, put X or put 10 inside the address. You will see. Now, in assembly language, also we can use something called labels in order to clarify the program. Also, we can refer to that labels. Labels, if we are talking about any other programming language like C or Java or C# or Java, do we have labels there؟ عندنا بروجرامر جيدين نوعا ما هنا. شوف عندنا labels بلغات البرمجة الثانية عندنا، ليش بنستخدمهم؟ طيب variable, but why we use it? Exactly, label variable صح، بس دائما بكتب بعديه column. For example, it's like a pointer. I can jump to that label. مظبوط؟ So we'll do the same thing here. We can do the same thing here. So in assembly language, we can use labels to clarify the program. How we will use the labels? Substituting, يعني نبدل a simple alphanumeric name for the operation code make the program much easier. What does that mean? It means like the following. Instead of say load 104, I will say load X. So X here is what? It's a label. Later, the value of X is 10. The value of X as an address. So it used to substitute or change the operation code and make the programming much easier. We can also substitute the labels with simple name to identify a name of particular memory address. So the memory address can be given a name. Any alphanumeric value for the operation code can take a name as well. So in this way, the writing style and the writing way of the program will be very simple. Now, let us make it more clear. Same code, same program, but we are using labels. So load X, add Y, store Z, terminate. Now, how I will use the label? X, 0023. So the address or the value of address X, which is 104, is what? 23 in hexadecimal or 35 in decimal. The value of address Y is minus 23. The initial value of Z is 000. So which one is better? Use a labels for the memory address or use the current memory address number? For sure this one. Now, what the directive will be used? It will be used to control, add constraint in the program. So here we have a program with labels only. At the right side we have a program with label and directives. So load X, add Y, store Z, terminate. Now X, comma, this is the label, decimal 35. So I can write hexa, HEX 0023. So Y, it will take a decimal value, minus 23. Z, I can keep it hexadecimal, 0000. So, is it clear how we can use the labels and the directives? Load X, this is a label. Add Y, we will substitute the address with what? With a label. For example, we can say F load X. So F here, F load X, F is label. It's like we write if else. Else halt. So else also, it's label. I will show you some examples, but I will not solve the TMA question because you need labels in TMA. But the overall idea, is it clear? The general idea of the labels and the directives? Come. Now, let us extend our code. We have studied 9 instructions: load, add, subtract, store, halt, skip condition, input, output, and I forget one of them. Jump X, go to the address X for the program count. Now, we will add another 4 instructions as an extension or extending to our previous ISA table. The simplest one is clear. I will start with the clear because it's very simple. Clear will put 0 in the accumulator. It will delete the value of the accumulator. Now, jump as X. Focus. It's like that when we have subroutine or we have a procedure in our program. I will explain it here. If we have a code, Java code, whatever, we'll execute this line, this line, this line, this line. Here, we have a function call. We call the function. So what we will do, we'll stop here. We will go to that function. We'll execute that function, then we will back and carry out the execution of the code. Right? لأن عندي تنفيذ برنامج بنفذ وصلت لفانكشن كول بحط بوينتر بروح انفذ الفانكشن بخلص برجع وبكمل تنفيذ البرنامج. How we can do this? In Mary by using jump indirect X or jump and store, sorry, this one jump and store X. So when we have jump and store, what we will do? We will store the current program counter at address X and we will jump to address X plus 1. We'll store the current program value, program counter at address X and we will jump to address X plus 1. Now, A, as I said, it's clear. Clear, we'll put 0 in the accumulator. This one and this one. Add indirect X. Okay? How it's work? Add indirect 104. Now, this is the accumulator. So add, we said it will go to the address 104. Add indirect, it will go to the address 104. What we have inside 104? 105, for example. It will not copy this to the accumulator. Add indirect. This one, it's another address. The actual data address. So we'll go to address 105. Inside the address 105 is the data we are looking for. It will be copied to the accumulator. So add indirect X, the value of address 104X is the address of the original data we are looking for. يعني العنوان X بيحتوي على عنوان الداتا اللي أنا بدي إياها ولكن ليست الداتا. هذا بيسموه indirect addressing. So X is another what? Address. It's not the data here. address inside address مش داتا يا ياسر لأنه داخل X عندي address لأدرس اوكي وصلت الفكرة exactly. So at indirect X go to address X, use the value at address X as the actual address for the data to be loaded to the accumulator.
في عندكم سؤال على add indirect x؟ we need it in the addressing mode. clear؟ واضحة هذه مهمة. واضحة للجميع؟ طيب. jump indirect x. say jump indirect. So go to address x. Use the value of address x as the actual address of the location to jump to. So jump indirect 104. We'll go to the 104. Inside the 104, jump to 105. So 105 will be taken to jump to. So go to x, use the value of x as the actual address of the location to jump to. Sorry, inside 105 we will have 50, so we'll jump to 50. So address for the actual address. Address for the actual value. Now, jump and store allow us to store a pointer, a reference مثلا زي ما معتز أو ياسر قال, and then proceed to set the program counter to different instructions. This will enable us to call a procedure or call a function or call a subroutine, and then we can return back to the calling point in our code once the subroutine finished. Clear? It will add 0 to the accumulator. So this is the RTL to the clear, and the RTL, the register transfer language or notation to jump and store. We will copy the program counter to the memory buffer register, the actual address to the memory address register, the data which the program value to the address X in the memory. Then we will go to the new address, we will add 1 to the accumulator, we'll increment the address by 1, we'll copy the address as a new value to the program counter. For all the Marie instruction we have discussed before, go, load X, add X, store X. X always is the direct address, we will use it. So all the previous instructions, they use the address explicitly. It's a direct addressing mode. Sometimes in Marie we can use a different addressing mode like the indirect addressing. So in the indirect address, the address of the address is given in the instruction. Load X or add indirect. So X here address to the actual address. Jump indirect X, X here is address of the actual address. So what we call this indirect addressing, not direct addressing. RTL for jump indirect and the RTL for add indirect mode. Now, any question? أي سؤال؟ طيب, my question. Write a simple code to calculate the following. 2x plus y minus z. How we can calculate or how we can write a code to do this? 2x plus y minus z. طيب. For example, ORG 200. I will start from what? Address 200. 2x load x. There is no multiplication. So how we can calculate 2x? 2x it's what? Two x is what? It's x plus x. So what we can do? add load X and add X. No 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 لا يا معتز، لا الليبل قلنا لا، الليبل بس اني ارتب برنامجي، هذا X الليبل. So how to do 2X? Load X. So for example the first address is 5. Add X. 5 plus 5, 10. Right? So 2 multiplied by 5, 10. So this is how we can find 2X. For example, if it's a 3X, load X, add X, add X. Now, add Y plus Y. So add Y. Minus Z, sub Z. Now, done, done, half. Now, X, comma, decimal, 5 for example, Y, comma, decimal, 10, Z, comma, decimal, 7. Done. Okay? Try to write it by yourself and execute it. I will show you how to execute and write Marie code today. So implement your Marie code, check if you have any error, correct the error if any. We will see how later. Now, before we go to the Marie simulator, I'm going to explain the addressing mode. Before I start, be careful, focus, it's very simple, it's 10 marks out of 50 final exam question. This topic I'm about to explain. Now, what's the addressing mode? Now we said that in the instruction we have 12 bits to specify the address from 0 bit to 012. Also, when we explore the instruction set, we say that we have two addressing. Load X, so X is the actual address, we will use it. We call this a direct addressing. And we have add indirect X, so here X is address for the actual address. What we call this? Indirect address. Now, in Marie, we have a different addressing mode, not direct and indirect. Okay? Multiple addressing mode. Now, one of the addressing modes in Marie called immediate addressing. Now, I will explain it by example here and you will solve the exercise. If the addressing mode is immediate, I have load 500. And I already told you that the addressing mode is what? Immediate address. What does that mean? This one is the actual data. So immediate, the data value will be given with the instruction load 500. So the value is 500. واضح immediate address؟ واضح؟ الأوريجينال داتا نفسها. Okay. Direct addressing. If it's load 500 and we use a direct address, we will go to address 500. Whatever we have inside the address 100 will be loaded to the accumulator. So 500 here is direct address of the data. Clear? So, immediate, the value will be given in the question, the data, if it's immediate. Direct address, this one is the address we will copy the data from. We will go to 500, we copy in the accumulator now. Indirect addressing. indirect addressing. Load 500, the address is indirect. We will go to 500. Inside 500 here, it's another address, 100. We will move to address 100. Inside 100 we have the data. We'll copy the data to the accumulator. What we call this? Indirect addressing. Now, the last one is the index addressing. What's the index addressing? You will given also something called IR, index register. Yes, add indirect. Now IR, suppose we have in the IR 300. So what if we say load 500 index addressing? Index addressing. It's like this. Load, if it's index, 500 plus the IR. So it's load 800. Now it becomes direct. So whatever we have inside the address 800, it will be copied to the program counter. So when it's index register, we will add the IR value to the address. The result will be the actual address we are looking for. So for addressing mode, one more time, immediate address, load 008. So 008, if it's immediate, will be the value of the accumulator. Now, direct addressing, load 008. We will go to address 008. Whatever we have, that value inside this address will be loaded to the accumulator. Now, indirect address, load 008. We will move to address 008. The value of address 008 is the original address. So suppose we have 2A0, we will go to address 2A0 and the value of this address will be loaded to the accumulator. Index address, we need to have the address plus the offset, the IR. So if the index register is 100 and we have load X, so it's load X plus 100. The result will be the address we will load the data from. يعني بنجمع ال IR مع X والناتج بيكون الادرس اللي احنا راح ناخذ منه الداتا. Clear؟ أي سؤال؟ أي سؤال قبل ما تحلوا انتوا؟ الاكسرسايز اللي جاي مش انا اللي بحله. طيب يلا. This is how the final exam question will come. Suppose we have the following memory. Remember, this one is the address and this one is the original data. What's the accumulator value for the following address? Load 800 and it's immediate. So what's the accumulator value? We have load 800 and the addressing mode immediate. 800. Exactly. Type. Load 800 and the addressing mode is direct. We will go to address 800. We'll copy the content of address 800 to the accumulator. ممتاز. Load 800 indirect addressing. It will be 1000. will move to address 800. Okay? 800 will contain the address of the original data. So 900. We will go to address 900. Now inside this address is the data we will load to the accumulator. Finally, load 800 and the index register 800, and we are using the index. So what we will do, we'll execute load 800 plus 800. So 1600. We will go to address 1600. We will copy the content of this address to the accumulator. How long you will take to solve this question? 2, 3, 4 minutes? It's out of 10. 10 marks. في شيء مش واضح في السؤال هذا أو الأدرسنج مود هذا؟ في حد مش فاهم نعيد؟ طيب. Now we done. I'm going to show you how to write a Marie code, how to run your Marie code. Okay? Now, you need to download the simulator from the LMS. Once you download the simulator and extract that file, you will get this data inside it. So you need to go to this one, Marie simulator, Marie sim. Just double click on that one. So this is how the simulator is looked. Download the simulator from the LMS, extract it, double click. Now to write your code, you need what? You need an editor. How to open an editor? File, edit. So here we can write our code. ORG 200. Load X, add Y, store Z, halt X, decimal 5, Y, decimal 10, Z, decimal 0. Now I write my code. It should correct. File, save as or save. You need to use it .mas, Marie assembler. So you give it any name. Okay, save. Now it's saved. But we still cannot run it. We need to make sure there is no typing mistake. How? Assemble the current file. If you got this one, assembly successful, which means there is no typing mistakes at all, the program will be working. If no, I will make a mistake. So Marie is case sensitive. File, save, assemble current file. So one of the operands is undefined. Here is in uppercase and here is in lowercase. So we'll get the mistake errors. One error found in the Marie. So one more time. Okay, you download the simulator from the LMS, you extract it, you go to the Marie simulator, Marie sim, double click. This is the simulator interface. File code here, you will save it .mas, you will type the code. Okay, after you write it, you can check there is an error, it will not work, XYZ, XY, store Z, I don't know what's the mistake here, Z, decimal 0, 5, save, assemble, now it's working correctly. Okay, so it's written stored correctly, we need to execute it. How will execute this one? File load. So this is the example. Okay. Now run the file. As you see, I have what? 001E is the accumulator. I can change the output. Accumulator become 30. So I can even hear the output, control it to be decimal. And you need to change it to be decimal in your example. Even the input, if you are going to give a data to the simulator, you need to change it to decimal. File run again. Now, I will load the bigger program. For example, let me say, okay, this is how we use the label. See, if load X, subtract Y, skip condition 400. Right, I will leave it for a while, this one. This 3 lines to check if X less than Y. Okay, jump else. So else is address. This is how we will use the labels, Yamatas. Now, I want to show you something very important now. Run set delay. So what does set delay? For example, let us make it 2000. 2 seconds, which means. Okay. Run the current file. So now we are in this one. Load X, load Y, skip condition. We jump to load Y. Store, jump to end F. In end F, we will print the output. The output is 10, high. So you can see what we are doing when you set the delay. For example, remove the delay. File run. Again, it's very fast. في عندكم أي استفسار؟ The index register value, the memory address register, memory buffer register, program counter. Then, do we have a question about the Mary? Is it clear how to write a code? You need this. You need to make some labels like this. And you need a skip condition to check if X less than Y. You need to use the skip condition to check if X greater than Y or X equal Y. How we can check if X less than Y? We'll take X, we'll subtract Y from X. If the result is less than 0, so X less than Y. If it's not, X bigger than Y. If it's positive, think about it like this. This is the clue I can give it to you to the TMA question. We have another tool can be used in Mary, is called the Mary database. This one show you exactly what happened at each fetch, decode, execute cycle. Check load. I will load this one. Now run. They give you as each fetch cycle, decode cycle, execute cycle, what happened for each instruction. What's the program counter value? We can set a speed, for example. 5. Restart. We set the speed. So we can slowly see what happened at each fetch, decode, execute cycle. Load. Once set the speed. Run. So now we can see in a slower speed what happened during the fetch. We are still in the fetch, decode, execute cycle. This is the Marie database. But you need what? You need the Marie simulator to write your code. You need this one. أي حد عنده سؤال عن الميري كيف نشغله؟ باقي عندنا TMA نتكلم فيه ونتكلم بالإن كلاس كويز. في حد عنده سؤال؟ عندكم أسئلة؟ طيب. Now for the TMA. You need to write a TMA, a Marie code, to perform the following pseudocode. Input a value for X. Input a value for X. How? Input store X. Yalla, I give you the code for this line. Input store X. Okay? After that, if X less than Y, we do not have if. We do not have else. Remember, I told you subtract from X from Y. Check if it's less than 0, bigger than 0. You can know which one bigger than the other one. I cannot give you any other comments. So X less than Y, the minimum will be X, else the minimum will be Y, and output the value of the minimum. Output the result. We need to print which one is minimum, X or Y, when we check which one is minimum. Now, you need to provide a screenshot of the simulator result, a screenshot of the Marie simulator after running the program, showing the value at the output window. So you need to give me or to show add a print screen to the Marie simulator after the output. Also, you need to provide the code itself in the document file. Now, some instruction will help you. Use the ORG instruction to start the program from address 300. So the first line in your code, ORG 300, input store X. What else? I don't know. Use your last university ID number as an input to X. يعني عندي سليمان آخر رقم عندك 9, so X value will be 9. عندي عمر last digit is 0, so X will be 0 as well. Okay. عندي معتز for example. وين معتز راح؟ معتز last digit is 4, so it will be X values. No. Also, do not forget the input and the output box in the simulator to decimal. So the input and the output in the simulator should be decimal, which means decimal. Okay. Following are the labels and the directives should be added at the end of your code. You can use another labels and directives. It's up to you. X will be at the beginning. The initial value is decimal 0. Y 5. The minimum as the initial value 0. So these 3 lines should be the last lines in your code. واضح السؤال؟ واضح السؤال؟ I told you, just to help you, you need a skip condition to check X less than Y or X greater than Y. اطرح X من Y تعرف مين الأكبر. ما بقدر أعطيكم أي تلميحات أكثر من هيك. I'm trying to help you in some way. يعني غير هيك أنا حليت سؤال خلص. صارت شغلة أحط الليبل وأطلع بس. نطبع طبعا output. No more على هذا. لازم تحله تشتغل. اللاست اي دي راح يكون 1، راح يكون اكس 1 يا ياسر. لا 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 ري ابلودد يوزنج، ارجع ارفعه، ارجع ارفعه، راح اخصم لك. اذا مش حاط الاي دي تاعك معناها ممكن مش انت، خلينا بالسليم وحط الاي دي تاعك. طيب الان next Sunday it will be the any classic quiz. The any classic quiz will be from 3 topics only. Yes 5 درجات بالجامعة. الآن أنا بتكلم عنه 5 marks 15 minutes. In the university you will answer on the same question paper. Now what's the questions? Sum of product, K-map, logical gates. Sum of next Sunday الأحد القادم next Sunday 29. طيب اسمعوني، في سؤال بالام تي اي كان معطيك جدول، طلب منك تطلع السم اوف برودكت، طلب منك ترسم الكي ماب، سمبليفايد الفانكشن، ترسم الديجيتال جيت، صح؟ اللي هو بيكون not A or C الجواب الاخير، مظبوط؟ نفس السؤال، مش نفس السؤال كنفس السم اوف برودكت، نفس الفورمات جاي يكتب. تمام؟ اكثر من هيك يعني خلص، نفس الفورمات جاي يكتب. تيبل سم اوف برودكت كي ماب ارسم. ايش قاعد بحكي الله يرضى عليك يا ريم؟ بقول لك نفس السؤال، نفس الفورمات، مش نفس السؤال كنفس السؤال كأرقام، نفس طريقة السؤال، جدول، طلع sum of product، اشتغل على الكي ماب، ارسم. طيب الآن أي ساعة؟ which time it's up to you. You will decide now either at 12 or at 2. طبعا طلاب الدمام تيجوا على الدمام وطلاب الرياض بتروحوا على الرياض. راح يكون في القسم عنده خبر هناك الساعة 12 و 2. الجميع لو سمحتوا نشوف يعني نمشي مع الأغلبية 2 إلى الآن. الأحد الساعة، الآن احنا مختلفين، في ناس بدهم 12 وناس بدهم 2، بس أنا بفضل يعني الساعة 2. We will have any classic quiz next Sunday الساعة 2. الأحد القادم الساعة 2 من 2 ل 2 وربع. Why؟ ما في تدريب ايش معلش، 15 دقيقة مدة الاختبار. طيب يا جماعة بالنص ساعة واحدة للجميع. K-map sum of product logical gate. نفس السؤال، طريقة السؤال اللي كانت بالمتر، طلع السم اوف برودكت وارسم الكي ماب واختصر وارسم اللوجيكال جيت. نعم سؤال واحد 3 فروع. نعم this week عندنا ما شاء الله 30 من 30 6 طلاب تقريبا، في 6 طلاب 30 من 30 جايبين. قلت لكم المادة مش صعبة بس بدها تدريب. عندنا 29 في 28. تكتب السم اوف برودكت يا ريم بتطلع السم اوف برودكت من الجدول وبتشتغلي عليه بالكي ماب. السم اوف برودكت اللي طلعتيه بتدخليه على الكي ماب، بتساوي جروبنج بالكي ماب، تختصري، الاختصار يرسم زي سؤال المتير. طبعا في شغلة اوكي. Do not forget to solve the online quiz. You must do it this week. All of you in the online quiz this week. There is another 5 marks for the online quiz this week. طيب, our exam next Sunday at 12. At 12, خلاص, at 12 you will receive an email and you will receive SMS if I can. أحد الجاي الساعة 12. ما في ميك اب للكويز. There is no makeup. There is no makeup. رتبي امورك يا ريم معلش، الكل بده 12. There is no makeup. ربع ساعة كلها، ربع ساعة الكويز، ربع ساعة. رتبوا اموركم معلش. next Sunday الساعة 12. نعم، ربع ساعة فقط. واذا كنتوا جاهزين ما راح ياخذ ربع ساعة. ما اظن، لا ما اظن راح يسمحوا لك بالرياض. معلش رتبي امورك على 12. كريم سؤال واحد، قاعدين بنقول سؤال 3 أفرع. روحي ادرسي. إذا بندرسه بنحل بدينا بنحل أي سؤال. أوكي؟ يلا يعطيك العافية. Next week will be the last class. الأسبوع هذا إن شاء الله. يعطيك العافية.